So for kind information, the meeting is being recorded. Okay. Yeah.
Yeah.
A very good morning. Greetings from Sri Venkateshwara College of Engineering. Very good morning to one and all present here. I welcome you all for the webinar, Realizing the Future with Reactions, a session dedicated to chemical engineering in the series of webinar event known as Pathways, organized by Department of Chemical Engineering, Sri Venkateshwara College of Engineering. Now, I request our respected head of the Department Chemical Engineering to welcome the gathering.
Yeah, very good morning to one and all. This is Dr. N. Mayappan, Professor Head of the Department of Chemical Engineering, Sri Venkateshwara College of Engineering. I thank our management, our secretary, Professor M. Shivanandam, our principal, Professor S. Ganesh Vaidyanathan. I welcome all the expert members, Professor Pushpavanam, Sri Mashilamani from INSES, an industry expert, and we have two of our alumni, Mr. Santosh and Ms. Bhuvaneshwari. This pathways will give an idea for the +2 aspiring students how to select the program. This will help them. Let me start with the Tirukkural. Kedil Vilichillam Kalli Oruvarku Madalla Mattrayavai. Education is paramount important. When it is very important, we have to have a very clear planning, and the pathway is very essential. We are starting this pathway from 29th of June. We have been doing it in alternative days. Today it is chemical engineering. We are here assembled here for chemical, and I welcome all the expert panel members for this webinar. Welcome all of you, all the expert and the participants. Now I hand over to Ms. Nalinikanth, the coordinator, to start. Nalin, you can introduce.
Yes. Thank you, sir, for your welcome address. In today's event, we are having expert speakers who are going to share their views on various aspects of chemical engineering. To begin with, we have Sri K. Masilamani, sir, Head of Engineering in Czech Private Limited, Chennai, a well-experienced chemical engineering professional to enrich us on various career opportunities for chemical engineers, followed by a renowned academician Professor S. Pushpavanam, sir, Institute Chair Professor, Department of Chemical Engineering at IIT Madras, who will throw light on skills gained through chemical engineering. Next, we have our own alumni, Mr. W.B. Sandosh, Senior Manager, Engineers India Limited, New Delhi, and Ms. V. Bhuvaneshwari, Project Manager, Shell, Bengaluru, to share their career pathway through chemical engineering at SVCE. To conclude, Professor N. Mayappan, Head of the Department of Chemical Engineering, will brief about chemical engineering program at SVCE. I request participants to post all their queries in the chat box. The expert speakers will be answering those in Q&A session, which will be at the end of all presentations. Now, to start the session, it's my pleasure to introduce Sri K. Masilamani, sir, Head of Engineering in Czech Private Limited, Chennai. He finished his Bachelor of Technology Chemical from Regional Engineering College, Tiruchirappalli, now known as NIT Tiruchi, in 1979. He has over 40 years of experience, out of which 22 years in abroad, and he has worked in engineering management, project execution, plant operations and commissioning, process engineering and control, process and safety design, concept, basic feed, and detailed engineering of oil and gas installation, both offshore and onshore, refineries, mining, petrochemical, and polyester plants. He started his career in Indian Petrochemicals Corporation Limited, known as IPCL, Vadodara and Nagatane, India, and later served at National Aromatics and Petrochemicals Corporation, Chennai, India, Arabian Industrial Fibers Company, Kingdom of Saudi Arabia, Querner Process both in India and in Indonesia, Ranhill Worley, Malaysia, and Technique, Indonesia. So out of his career, he has spent 15 years in Technip, Indonesia, and currently serving as Head of Engineering in Czech Private Limited, Chennai. Sir, it's our privilege to have you here, and we are eagerly waiting to know more about various career opportunities in chemical engineering. Sir?
Thank you.
Yes. Can I?
Maslamani, sir, please take your mic, sir.
Yeah,
One second.
I'm ready. Yeah.
Thank you, sir. Please come.
Okay. So I will sir, yeah. So do you want a few words and later on going for the PPT, or you want to go from now? Say a few words or go to the PPT.
Yeah, yeah, you start the PPT. I'll start from the top page and then proceed further.
Thank you, sir. Just a second, sir. Are you able to see the slides, sir?
Yeah, yeah. Okay. Good morning to all. Uh, as explained before, I'm Masilamani, working as Head of Engineering in Inzex Engineering Private Limited, Chennai. Uh, I'm a hardcore chemical engineer, and I take pride in telling that I'm a chemical engineer. Entire 40 years, as explained before in my curriculum, I've done most part of chemical engineering activities in my industrial career. Started with IPCL, Indian Petrochemicals Corporation, where I worked in a xylix plant and dimethyl terephthalate and ethylene oxide, ethylene glycol plants. Then I moved to Aerochem in Chennai. It was supposed to be an aromatic project, which did not take off later. Then I moved to Saudi, Saudi Arabia. It is for commissioning of a polyester plant, aromatics and polyester plant. Came back and from the factory to the office atmosphere. I joined Governor Process Systems in Bangalore. From petrochemicals, I changed to oil and gas, both offshore as well as onshore. From there, I went to Malaysia on deputation. From Malaysia, I moved to Indonesia, Governor first, and then to Technip, all multinational companies, mainly in the oil and gas business. When we say oil and gas, it both onshore as well as offshore. Offshore, other than the drilling, once the oil comes out of the well, it is how it is purified and then taken to onshore. Everything is dealt with, and the engineering for that is done by the companies. Now, chemical engineering itself, basically in your curriculum, you guys will focus on unit operations, then heat and mass transfer, stoichiometry, and other things. Okay, now these three things which I mentioned are going to have a larger contribution in the industrial atmosphere. In your day-to-day activities, unless you join some manufacturing companies where you will be doing monitoring the plant performance rather than doing your own uh, calculations and other things. If you are joining an engineering company like the one I am in right now, many of the curriculum you do in your academic course will definitely is going to be useful once you come to the industry. Okay. Now, can we go to the next slide, please? Okay. Now, in my speech, I'm going to cover basically the three aspects. One is the chemical engineering career, then industrial job opportunity, career options. I want to make it short and sweet. So, can you go to the next slide? Next slide. Yeah. Okay. Now, role of chemical engineers in an industry. Typically, the role of chemical engineers is going to be like conduct research to develop new and improved manufacturing processes. When we say research, develop new and improved manufacturing process. See, chemical engineers, they are not scientists. They are more on the technology side. So the scientists develop the basic scheme, and that will be converted to a technology by the chemical engineers. Then perform process simulations and generate process flow schemes. After technology is evolved, the chemical engineers will perform the process simulations and generate their own process flow schemes. You will have to select specific processing facilities to combine into a production facility. That will be done by the chemical engineer. Then perform design calculations and generate drawings. Design calculations basically sizing calculations, like you have in different unit operations, like compressor, separator. You will have to do the sizing of the separator, sizing of the pumps, etc. That will be done by the chemical engineers and generate drawings. One of the major drawings developed by chemical engineers or process engineers are P&IDs, piping and instrument diagram. So which will it's called Bible of the entire project, where you will have the complete process described with the piping and all the instrumentation associated with that. Those drawings also will be done by the chemical engineers. Then conduct tests and monitor the performance of processes. Like you'll be taking field trial runs. If you're in research, you'll be taking field trial runs to improve the productivity and monitor the performance of the particular plant. Then you will do the troubleshooting problems when within manufacturing processes. Then you are working in a plant, you get some problems, like you're not getting the product purity, or you are not able to meet the operating conditions, etc. That's called as troubleshooting. You look into that, you probe into that, and solve the problem. That's called troubleshooting. Then evaluate compliance with safety and environmental regulations. Very important aspect for a chemical engineer is we pay more attention to the compliance, like regulations, safety regulation, environmental regulations. So whatever the processes we have, we need to avoid incidences like bhopal. The safety has to be taken care and given a much more importance than anything in a chemical process. So you have to evaluate what can go wrong and try to address during the project stage, during the engineering stage, as well as during the plant operation stage. Then estimate production cost as well as the cost estimate for any project. That's all done by the chemical. So these are some basic roles of the chemical engineer. So if you are with the licensor, as I said, you will develop the technology. If you are with a manufacturing facility, you will be monitoring. Or with engineering companies, you will do entire like calculations. Just next slide, please. Okay. Now this is the important slide which will be useful to many of you. Okay. Job profile for chemical engineers. Like once you finish your chemical engineering, either of a bachelor degree or master's, once you enter into industry, these are the jobs which you may look for. You know, once you enter into the industry, like if you go to the manufacturing side, you will be called as operation engineer or production engineer. Okay. If you are going into manufacturing and in engineering, you may be doing optimization, you know, like you need to do the energy and the cost saving. So that's called optimization. Then debottlenecking engineer. Debottlenecking, there are some problems in the plant which needs to be resolved. That's called debottlenecking. It may be it may be for meeting the production target. It may be for taking care of some of the safety issues. It may be for getting the production on time. Like within certain period, you have to achieve your target. So that also will be the debottlenecking will be done in the plant. Then safety engineer. Majority of the time, the plant safety will be taken care by the chemical engineers. And once you work with engineering companies also, there's something called process safety department. where the chemical engineer will do majority of the safety aspects related, especially if you are working with a hydrocarbon or a toxic chemical handling plant design. It's very important that you pay more attention to the safety issues which may come. Like during the engineering itself, we will be doing something called hazard, like hazard operability and hazard identification and skill, which is called skill integrity level. These kind of things will be done during the project stage itself, where a chemical engineer will do the role of the safety engineer. Then process engineer, as I explained in engineering, the process engineer plays a major role. He is like the pilot or captain of a ship. So the whole activity in an engineering project starts with the process engineer. Process engineer envisaging the overall project itself, like what kind of a project is it? Is it a concept, a front end, or a detailed design? And looking at various options in the process schemes, like whether I can go for this operation, whether I can go for the other operation. So the process engineer has to look at various processing options and select one which is technically and economically feasible. Okay, we call something called feasibility study that will also be done by the process engineer. Then process engineer may work as project engineer who will run the, like you'll be part of the project management, especially if you are engaged with the EPC companies, engineering, procurement, and construction companies. There will be designation called project engineer or project manager. And many of the times, the chemical engineers will be associated with the project engineer role, who will not only monitor the performance of the engineering and performance of the procurement and the construction, but at the same time, he will ensure that the project is completed within the time period. That's very important for EPC companies. Then costing engineer, as I said, the overall project cost has to be within the limits. So the cost monitoring will also be done by the chemical engineer, like certain allocations done in the beginning of the project towards certain activity, whether they are followed properly and whether the control is enhanced, everything will be taken care by the costing engineer. Then research engineer, like if you are in the R&D, a pilot plants, like as I explained before, chemical engineer is not a scientist, but he is more towards the technologist. Okay, so research engineer, chemical engineer may be associated with the pilot plant activities. Then quality control, like in laboratories, major laboratories, chemical engineers may be engaged as quality control engineers. Okay, so these are the some of the major aspects of a chemical engineering career. Once you complete your academic course, you may enter into the industry, as I explained, the three kinds of industries, wherein you will fit into different roles like what is specified here. Next slide, please. Now, the relevant industries for chemical engineering career. So, for the past 2 decades or even 3 decades, majority of the chemical engineers were absorbed in the oil and gas, both upstream and downstream. When you say upstream, it's more to do with the extracting oil or gas from the sea or the onshore. Okay, and processing of the gas, converting the gas into LPG or LNG, they all come under the upstream industry. When we call downstream, it's towards the processing of the gas and the oil in the onshore facility. That's called downstream facilities. Refinery and petrochemicals. Majority of you will be aware the major use for fossil fuels are made in the refinery as fuels like kerosene, diesel, and petrol, and petrochemicals for production of plastics and other things. Okay, so these are the industries where in the past decade or 2 decades, majority of the chemical engineers were actively involved. Fertilizers and industrial chemicals is, I would say, a bygone era, maybe 30, 40 years back. These are the areas where chemical engineers were involved. Mining, cement, and coal. steel and inorganic metals, food, beverages and cosmetics, paints, adhesives, additives, pulp and paper, power generation, water treatment, renewables, electronics, and nuclear. There are so many industries wherein chemical engineers can find a career. Only thing is, you have to choose the right career which is of interest to you. Like as I said, when I entered my college in 40 years back, in the interview, my principal asked me like, which department you would like to join. I said the first, second, third choices are chemical engineering. Okay, so I never regretted my selection. Even after 40 years of industrial experience, I still crave for reading more innovative things in chemical engineering so that I can apply in industry. Next. Okay, now job opportunity. First thing, definitely you have to have the demand, and then you have to look for the right opportunity. So there are definitely demand for chemical engineers who can excel in critical problem solving and can work in multidisciplinary teams. Other than the R&D, where you can work in individually, once you enter into a manufacturing industry or an engineering or EPC industries, you have to be a team player. And you should, one of the main things people will look for in a chemical engineer is the problem solving, critical problem solving, and giving a solution to others. People will look at chemical engineers to give solutions. Like I have certain problems, how I can overcome. They will definitely come to the chemical engineer or the process engineer. Demand for consultants, facility, and process engineers. Consultancy, if you are having your own consultancy for chemical engineering, for giving process engineering service, definitely there are opportunities. And when you say facility, that you are working in a manufacturing industry, you are called a facility engineer. Especially if you are working in oil and gas, you are called as facility engineers. And process, you are called a process engineers when you are working in engineering companies. Then there are demand for environmentalists dealing with environmental sustainability, like cleaner ways to produce and optimize energy consumption. See, as I said before, these days we are more and more bothered about the environmental issues. So, attention from chemical engineers are required for these environmental issues, and there are plenty of opportunities for chemical engineers to work into this aspect and to help help to tackle the global warming issues. Okay, next slide, please. Now, there's a big list of manufacturing companies here. I just listed a few. There are so many other companies. Majority of these companies you will see are either in the oil and gas or in the refinery and petrochemicals. Okay. So as I said, this is one area where there are plenty of opportunities for chemical engineers to use what you study in your curriculum. Like companies like Indian Oil Corporation, Hindustan Petrochemicals, Oil and Natural Gas, then Steel Authority of India, Bharat Petroleum, Reliance Petroleum, then SR, like that. There's a big list. You guys can go through that. Each and every one of these companies, they may be conducting campus interviews. I don't know. Maybe as of now, the opportunities may be less because of the low oil price. But uh, as always seen, there's always a sine curve. There will be a downward trend. Again, there will be an upward trend. So you guys don't lose hope. As of now, the opportunities may not be much. Definitely, it will come up in the future because mankind cannot live without cannot live without fossil fuels. Slide, please.
Next.
Okay, now abroad. See, as I said, my CV, majority of my career is spent abroad, and I have worked for doing projects for companies like Shell, BP, Chevron, ExxonMobil, Total, Petronas, Aramco, and ADNOC. These are all major oil companies, multinational companies, okay, in the world. So either you can get directly an opportunity to work for these companies, or you can be doing engineering for these companies. These companies do exploration and production, like what we call subsurface and surface facilities. When you say subsurface, below water, there are some work being done nowadays, what we call subsea. When we extract oil, it's typical to whatever we do for your water, bringing water up, like doing a bore well, you bring the water. Similar to that, you do a boring to get the oil or gas out of the Earth's surface. Once it comes out, it has got both liquid hydrocarbons, gas, and water. The production facility, surface facility is what we call treating the dirty items and then to the purification. Okay, the surface operation, as I said, it's more to do with the purification of the oil and gas. Then pipelines, we have to transport gas and the what do you call the oil to the land. That will be done through the pipelines. So pipeline engineering, more of the pipeline engineering will also be done by the hydraulic engineers, whether particular gas or station at pressure and temperature required. That is all the chemical engineers, process engineers. That's called flow assurance. Okay. Now, other than this, okay, can we go to the next slide? Okay, before going to the career options, I will say a few things on the software which the chemical engineers should be familiar with. Typically, you get hands-on experience on some of the softwares during the curriculum, but it is very much essential that you are familiar with the industrial softwares used by the chemical engineers once you get into the industry. The typical process simulation softwares are HiSys, and then there are softwares like PipeSim, PipeNet, then FlareSim, FlareNet, Fast, Smart Plant P&D, etc. These softwares you can get yourself familiarized on your own, because these things are going to be much helpful once you enter into the industrial platform. Now, for the career options, as I said before, the oil and gas energy sector, you can enter into engineering, procurement, and construction companies. Engineering consultants, like who can do the concept, front-end, and detail engineering, and the construction companies themselves. But once you enter into construction companies, the application of chemical engineering, whatever you study, that will be limited. Majority of your knowledge gained in the curriculum will be used if you are entering into an engineering company, engineering consultant. Okay. Major EPC companies in India like Larsen and Toubro, Afghans and Roof. Engineering companies in India like Engineers India Limited, Technip FMC, Saipem, McDermott, Solution, Petrofac, Amek, and Inzec. I'm mentioning Inzec here. This is a joint venture between India and the Czechoslovakian company. We are more into oil and gas and refining sector. Okay, next please. Now, when we studied chemical engineering, biotechnology, and there are so many other branches of which have come up recently, like food processing, were all part of the curriculum of chemical engineering. Biotechnology is one area where you can get into specifically where you will be dealing with degrading waste, plastic degrading by bacteria. That's one area where everyone is looking at the chemical engineers nowadays. Then converting waste into useful products. In refineries, we have something called bottom of the, there's a residue which comes out of the crude oil that is converted to useful products by lot of new processes which has come up. Things like that. So wherever there is a industrial waste, which can be converted to useful products, definitely uh, the technologies can be useful. The chief recruiter for biotechnology, Tata Chemicals, Galaxy Surfactants, and Sumitomo Chemical Limited. Next one, please. Genetic farming and consumer goods. Chemical engineers study genetic modification of fruits and vegetables, attempts to increase yields. Like when I was doing more on the oil and gas, I used to feel that we are doing injustice to the mother nature. So definitely, farming and consumer goods, chemical engineers can control, which will increase the yield and not making any damage to the environment. So area includes researching methods of making agriculture more environmental friendly and new methods of processing and conserving oil and water. The oil, the soil should not be corrupted and the water should not be contaminated. These are the areas where the chemical can be applied. Next, please. Okay, now green processes. When we say green processes, it's more towards the sustainable development, green technology, okay, renewables, like water management, energy efficiency. And when you say a green process engineer, you'll have to develop environmental friendly products, select processes that minimize pollution, use less hazardous materials, develop semiconductors which will not be harmful to the environment. And whatever the products you develop have to meet the emerging laws and regulations for environment. Next, please. Okay. Other one is quite interesting. Chemical informatics. Majority of the youngsters are interested in the IT sector, information technology. So you can use the information technology in the chemical engineering field as well. That is called chemical informatics with application of information technology in chemical industry. Major aspects of chemical informatics are information acquisition, information management, information use, chemical computation, biopharmaceutical computation. Basically, development of the database, which will be quite useful for running the plant efficiently. Chem informatics apply to data analysis for various industries like, as I said, oil and gas, pulp, paper. Majority of the industries, they use the chem informatics to maintain their database to improve their processes. So if you are more interested in IT field and at the same time getting into the chemical industries as well, you can get into these areas. You can be a guy who is more involved in the chemical informatics. Next, please. Then higher studies and majority of the time, okay, immediately you are not getting a job, you can get into masters, specializing in any one of these disciplines such as catalysis and reaction engineering, polymers and complex fluids, molecular simulations, biochemical and bioprocess engineering. Like where you can really need to focus will be the energy storage, zero water discharge, zero flaring, and alternate food design, disposal text design. Now, okay, these are the areas where you can go for higher studies. Now, the last slide. The components of a successful career in the future will be you have to be a guy who is more interested in problem solving, math minded. It's very important that, and when you say you are an engineer, you have to be math minded. You should be able to do mathematical calculation and to solve problems. And you have to be creative. or innovative. That's very, very important. Even after 40 years, I read many times in the journals, in the internet about the new innovations coming up in the field of chemical engineering, so that that could be applied in our day-to-day activity. And very important is the self-assurance. You should be assured of your own activity. That's very important. And you have to be a IT literate. That is very essential for the near future. Thank you. Thank you very much.
Thank you, sir. Thank you, sir.
Thank you, sir. Okay, thanks a lot, sir. What you have indeed presented as an encyclopedia of about industrial aspects of chemical engineering. It is not only industrial aspects, you also touched upon the research aspects also. So, as a chemical engineering professional, you have explained practical day-to-day professional engineering uh, about chemical field. Thank you, sir. For our next topic on skills gained through chemical engineering, I am delighted to introduce Professor S. Pushpavanam, Institute Chair Professor, Department of Chemical Engineering at IIT Madras. He completed his Bachelor of Technology at IIT Madras in 1984. Later, he did his Master of Science at University of Florida, USA in 1985 and completed his PhD at the University of Florida, US in 1989. He has over 30 years of academic experience. He started his career as a research associate at Tata Energy Research Institute, New Delhi. Later on, he served as assistant professor at IIT Kanpur in 1989 and joined IIT Madras as an associate professor in 1997 and grew as professor and also served as head of the department. And since 2017, he is serving as institute chair professor. His research areas include hydrodynamic stability, nonlinear dynamics, microfluidics, energy production and efficient utilization, green engineering, ecochemistry and kinetics for sustainability, and flow visualization. For our country, India, he served as a member of Scientific Advisory Committee, Center for High Technology for 2 years. His international interactions with other institutes includes uh, he, uh, he, as a recipient of renowned Fulbright Fellowship, he visited University of Florida, Gainesville in 1996. He's serving as a visiting professor at University of Ghent, Belgium since 2009, and he is serving as a visiting scientist at Max Planck Institute for Dynamics of Complex Technical System, Germany for the past 12 years. As a student and academician, we are extremely happy to have you, sir. Kindly share your thoughts.
Yeah. So thank you for the introduction, Nalinikan, and it's a great pleasure for me to be here. I hope my audio is clear.
Clear, sir.
If you have difficulty with my audio, let me know. I will then switch off my video, and then the audio may improve. I think I'd like to first begin by congratulating SVCE for this initiative of arranging this webinar. This is a very proactive measure from SVCE, and that shows their dedication to academics and to teaching, and which is one of the reasons why SVCE is rated as a top-notch college of engineering in Tamil Nadu, in Chennai. I think it's a very good thing because today most of us are confined at home because of the situation, and this kind of an interaction where you use the internet is good, and you're also recording it, so maybe other people can also benefit. I think Mr. Masila Mani has done a great job of trying to talk about all the opportunities in industry. His focus was mainly on what it would be when you graduate, and I would like to talk about situation college. The
Excuse me, sir.
target
Your audio.
audience that
Excuse me,
we
sir.
have are students who have finished
Excuse me, sir.
plus two
Professor.
and who are
Sir, Professor, there is a voice break. Professor, there is a voice break, please.
One of the things, I just switched off my video, which,
Yeah.
Yes, sir. Yes, sir.
Yes,
It's
sir.
better to put the video.
yeah, one of the first things which you need to do if you want to be a good engineer is to have strength in basic sciences. And by that, I mean physics and mathematics. These are the two areas you need to have real passion for and interest in. Be a good engineer. And I'm talking about engineer, not just chemical engineer. And strengths in the physics and mathematics. Okay, and so students who are looking at engineering as an option should have this in their as their strengths, and this is what will help them excel tomorrow when you graduate. The passion that Masilamani sir was talking about has to be based on these fundamentals, and then SVCE is going to help you grow in these areas, develop concepts, and then excel in industry. The in any engineering department, what we do is, harness your ability to analyze situations. Now, Masilamani sir, in his first slide, he had all these big chemical plants, and you could just see the scale of the operation of these plants. So, as a chemical engineer, your focus is mainly on trying to make sure that things are running smoothly in the plant. Okay, and for this, you need to have good concepts in the courses, okay, which are basically going to be taught in SVCE or any chemical engineering curriculum. And the essence of all those courses are the fundamentals of physics and mathematics. I keep repeating this again and again because the only difference is the examples which different departments will talk about in that particular curriculum. Okay, and the one of the nicest things about chemical engineering curriculum is that it is one of the most versatile and most interdisciplinary curriculum that you have. The breadth of courses that we cover courses from a whole wide range. We talk about thermodynamics, kinetics, and these are courses you will get exposed to. It helps you specialize in the different industries that you got a glimpse of. So this breadth of courses that you get exposed to in chemical engineering curriculum helps you perform well in areas like biotechnology, which was touched upon earlier, in pharmaceutical industry, semiconductor industry. Though Masilamani sir has main experience in the oil and natural gas, I mean, but the thing is, and he was giving a lot of focus in oil and gas, but he also saw opportunities which are available. And I think this ability for a graduate
Sir, there is a voice break. Huh?
Yeah. I
So, sir,
think it's
please,
because of network issues.
network
Yeah,
issues.
network issues are. It's coming high traffic and low traffic kind of thing. So it's going on and off.
Professor, please.
Uh, yes, sir.
Sir, Professor.
It's not there. Sir, so I think it's network issue only. He has left the meeting and he'll can join us. That is, we'll wait for some 30 seconds. He'll join us back and then, yeah, we'll see. I think he has some connectivity issue and it got disconnected. Yeah.
Nalin, sir is
Yeah,
coming.
okay.
Please, sir is coming on the
Yeah,
line. He said network issue is there.
Yes.
All will come.
We'll wait for 30 more seconds. Yeah, we'll join.
Yeah. He's about to join us.
Yes.
Sorry for the interruption. Very shortly, Professor will join us.
So, participants, please post your questions in the chat box. We will address them at the end of the in the question and answer session individually.
There is a question. Please highlight the business and job opportunities after completion, sir. So that question is to be taken up, and we have to brief him the business and job opportunities whatever we have. We can also ask the professor to address this question when he comes back.
Yes, sir.
He said he's on connecting it. He's connecting.
Okay.
Sir is back. He's back.
I think he'll join. Oh.
Yeah, hello.
Yes.
Yeah.
Yes, sir.
Sorry.
Yes, sir.
We're
Please,
waiting for you,
please,
sir.
please.
Yeah,
No
no problem, sir. We're waiting for you.
Yeah, sorry. I mean, we just had
Yeah,
a internet problem. So I was talking about the fact that, if I remember, I was talking about the fact that many people confuse chemistry with chemical engineering.
Yes,
And
Sure, sir.
so the point is, we have, that's a wrong notion. You may like chemistry a lot, but chemical engineering is completely different from chemistry. And I think it was hinted earlier in the presentation that if you are interested in doing things in a small scale, in a test tube, then what you are doing is chemistry. But what we are interested in is trying to see what you do in the lab, which is what the chemist does, and tries to do a large scale production in the factory. And then when you're really scaling up and doing this large scale production, you know, the factors that you have to think about are completely different. For example, if you have a very exothermic reaction, okay, there's going to be a lot of heat generated, and to make sure that you have a safe operation, you need to remove the generated in the reactor. And so what we teach you in chemical engineering is to calculate how much heat is being evolved in the reaction, and how to design the reactor to remove the heat that is produced, so that you can have safe operation of the reactor. And I think this is one of the examples which I thought I can share with you. Similarly, so you can see that the whole focus is on the heat released and designing of equipment for removing the heat released. In a very big chemical plant, you will be transferring liquids from one unit to another unit. So you need to have pumps which will do this job. So all these different aspects is what we focus on in chemical engineering. And in fact, the amount of chemistry courses you may be doing may be the same as what people in other branches do. Maybe you may do one extra course in chemistry at best. So chemical engineering is more of how to use these fundamental concepts to do this large scale production. And if you and the other aspect which was touched upon earlier was safety. You know, chemical plants are inherently dangerous, but then we have enough experience, and if you are your fundamentals are strong, your focus is going to be on safe design and operation of these plants. So if you understand how the plant behaves, what is the physics, what are all the different things that are going on in the system, you can design it in an efficient way, in a safe way. And that is what our focus is. I mean, very recently you had a small disaster in Visakhapatnam. There was gas leakage. Now, that is unfortunate, but you know, that doesn't mean you close down the plant. You have to figure out what happened, and then you try to install safe practices, safe procedures. Okay, and I think this was also touched upon by the earlier speaker. So what you do as a chemical engineer and what you are taught in the chemical engineering curriculum is how to make these designs. The other aspect which is very important is, I mean, today, if you hear our government, our Prime Minister speaking, he speaks about Atmanirbhar. He speaks about self-reliance. So there is a lot of push, and the only way you can be self-reliant is if the people are going to focus in the manufacturing sector. Okay, the era of IT is only a service tool which can be based on manufacturing. So, and therefore, in the near future, with the government's initiatives, I believe there is a lot of scope, especially for chemical engineering students who are going to be interested in the manufacturing sector, to have opportunities which were not there before. And all you need, or the is interest in such an area, interest in working in these kinds of areas, and interest in basic science, because that's when the challenges which Mr. Masilamani was talking about, you will be able to come up with innovative solutions. Okay, so the idea is to have a good grounding in fundamentals of chemical engineering, which will help you safe operation of plants and efficient operation of plants. The one of the recent things that you have, which again is only what a chemical engineering can do, is this business of not only operate in such large scales as the chemical factories that you saw earlier in the earlier slides, but we have something called lab on chip technologies that we are developing now. Let me explain to you what I mean by that. In almost every household, there would be somebody who's diabetic, the way things are going. And in the good old days, we used to, give a blood sample in the hospital or a lab to get our sugar analysis done. So, but today we have these small handheld devices which can be used, okay, at home. and all you do is you have a small strip, okay, which has an electrochemical sensor. You prick your body with a small pin. A drop of blood is added to the strip, and you get a reading. Now, this particular glucose sensor, which is a handheld device, is basically based on chemical engineering principles. So, the point I'm trying to make here is that chemical engineers can operate not only on these large scales of big chemical plants, but also in the small scales of handheld devices. So today, chemical engineers are active very much on developing these kinds of devices where you can do the tests sitting at home, because you may be in a remote city, you may not have a remote village, you may not have access to a lot of healthcare facilities, but if you want to do regular monitoring, can we do what is called point of care diagnostics? So you don't have to take the patient every time to a city for getting the checkup done. So these are the kind of new challenges which exist. So you need to therefore understand that even the way the chemical engineer is viewed in the global scale, the job skills that you have are completely diverse. He can operate from this large scale of a chemical factory to this very small scale of developing small devices which can be used for point of care healthcare area. You can also do it for testing water quality in remote areas. And your imagination is what is going to prevent you from doing great things. So if you are imaginative, if you are creative, all the concepts which are taught by the college, you can use them and come up with new technologies, new applications, which are going to be very relevant to society. Today, in addition to this entire focus on big industries, we can also see that there's a lot of push towards entrepreneurs. A lot of people are encouraging youngsters to start their own thing, their own company, own business. And you need to start as a chemical engineer. You will be in a position with the skills that you learn to start companies which are going to provide technological solutions to problems which exist. And every day new problems are coming, and you have to be aware of what are the problems which the societies are facing. For example, you can look at the problem of pesticides which are used in the agricultural crops. And what you want to do is make sure that the food you're eating, the rice, the vegetables, do not contain any pesticides. So is it possible to develop sensors which can detect the presence of pesticides on these crops, on these vegetables? And is it something which can be there at the household level, so that when you go to the market, you can quickly check whether the crop, the vegetable you're buying is indeed harmful or not? So, I mean, you need to be imaginative, you need to identify problems, and as a chemical engineer, the skills you develop will help you find solutions to the problems which exist. I think that's the nice thing about why one has to do engineering, because in the college, what you do is you get the foundations, you get the fundamentals of all the different courses, and you apply these fundamentals in finding solutions to problems. Okay, and there are problems, new problems coming every day, and you need to sit down and see how these problems can be addressed. Okay, and which are the problems which you find exciting for you to solve. And different students will find different problems exciting. So you need to find people who can possibly make a group. I think Masila Mani sir was talking about teamwork, and I think it's very important to have teamwork. You need to have a small group of people who will work as a team together and try to solve these problems. But while there are many challenges, many solutions possible, the everything is possible only if you have a strong foundation in the courses that you do. So that is the most important thing. I think there is usually some confusion in the minds of students, as to which discipline to take. If have decided to be an engineer, whether to do chemical engineering, whether to do mechanical engineering. And as I told you before, chemical engineering is very interdisciplinary. Not only is chemical engineering interdisciplinary and gives you a broad base, but the opportunities that exist, I mean, research, in fact, even the way the curriculums are structured today in the different colleges are also breaking down. 30, 40 years ago, we had these compartments: mechanical engineering, civil engineering, chemical engineering. So today, these divisions are actually breaking down. There are people who are chemical engineers who can solve civil engineering problems. There are people in civil engineering who can solve mechanical engineering problems. So, this is just something which is there in your mind, whether you are a civil engineer, whether you are a chemical engineer. Idea is you are an engineer at the heart. And at the bachelor's level, it really doesn't matter too much because we are only teaching you fundamental concepts. It's only when you go to a higher education, when you go for a master's or a PhD, then it makes some difference as to whether you are going for, what is the area of research you are going to be working in. So I would not worry so much about, the thing. The only USP of chemical engineering is it gives you strength to go into different areas at the end of your degree. You can, like he said, you can go into the IT sector, you can do data analytics, you can go into oil and gas, you can go into wastewater treatment, you can go into sustainability, because these are the buzzwords. And the chemical engineers are the best for addressing all these problems. I think he also mentioned about simulation packages, and these are also very important tools, because when you want to design a chemical plant or when you want to analyze the system, you can't build up a plant and then find out, oh, this plant is not working, this plant is not efficient. So you want to be able to do things on the computer first. On the computer, you will try to simulate the behavior of the plant. What do I mean by that? I mean, there are simulators for the pilots, how to ride the aeroplane. There are simulators for people who are driving the car. So to give the sense of, so for practice sessions. So similarly, we write equations and we do mathematics and physics and try to design the plant on paper, look at the performance and do different combinations. And that's when we can do the optimization of the chemical process plant. Okay. And once you are clear on paper that this design is good, then you go and build your plant. Then you go and build your plant on the basis of your calculations. So this is broadly, in a very general sense, what are some of the opportunities that you have? What are some of the challenges that you face? What I like to sum up with is the college education in SVCE will basically equip you with skills to address these kinds of challenges when you graduate. It could be in the chemical engineering industry, it could be in any other industry, but the fundamentals are that are imparted by this college are what is going to basically help you do well. Okay, thank you very much, and I will be happy to take questions at the end.
Thank you, sir. Thank you, sir.
Yeah, thank you.
So thanks for your wonderful talk, sir. That was a really a big booster. So just to summarize what Professor Pushpana was saying is, there is a solution. I mean, there is a problem and you need to find a solution. And for that, whatever the skills required, we need to acquire. As an engineer, if you are having those engineering presence of mind, then you will acquire those skills. Either it may be civil engineering basic concept or electrical or instrumentation or information concepts or programming packages. Chemical engineers are provided with a basic skill set which will help them to acquire those skills and solve the problems. So thanks, sir. Thanks a lot. And now for our next speaker, let me give a short introduction about our dear alumni, Mr. W.B. Santosh. He's serving as a senior engineer, Engineers India Limited, senior manager, Engineers India Limited, New Delhi. He has completed his BTech Chemical Engineering from SVCE in 2008. He has 12 years of process design experience, and his expertise includes gas processing offshore, refinery, mass transfer, hydraulics. As a process design engineer at EIL, he has completed several Indian and international chemical engineering projects. Hi, Santosh. I welcome you to share your career pathway through chemical engineering at SVCE. Okay,
Welcome, Santosh.
welcome, sir.
Join us.
Good morning, everyone here. And it's a privilege to be part of gathering here. And I thank SVCE to invite me for this fantastic gathering. At the outset, it's a fantastic initiative done by SVCE. I just think about my school days when I was in 12th standard in 2004. So I had to really look up a lot into to decide on the stream of engineering. Now I think it's on your plate for the students here, and it's a fantastic initiative, sir. I thank you all. I think expert is not a right adjective I will use for myself. I'm still learning. I consider myself very infantile in the stage of my career here. It's just 12 years down the lane when in front of Mr. Masilamani and Mr. Pushpanam here. So I believe like they have covered almost all the things with regard to what kind of what do you say, like the career opportunities, etc. I would like to give myself say about myself a brief introduction about myself, and then I would share my insights as a student. I still feel so. Yes, I still interact with my professors here. So I would like to take you through the journey. As an alumni, I would like to show some light on how I had evolved into an engineer from a graduate. So I would like to give a small presentation, just a few slides. My name is W.B. Santosh. I am a senior manager in process design department, Engineers India Limited. I have completed my BTech Chemical in the year 2008. My field of experience is gas processing, as we have seen the presentation of Mr. Ramani. Some of the activities he has listed I am currently doing. I am doing the process design. I am a process engineer in Engineers India Limited. It's a PSU, it's a public sector under the Ministry of Petroleum and Natural Gas. We are basically into hydrocarbon industry, and my profile is about gas processing in offshore and then refineries. And my field of experience is in mass transfer hydraulics for trays and columns. And these are the major projects I have worked with, Indian projects. Like currently I'm working for the petrochemical offsites in Hindustan Mittal Energy Limited. And these are some of the clients listed by Mr. Masilami. I worked like ADNOC and some PDVSA, Venezuela, and Indian clients like IOCL, ONGC, HMEL, etc. First of all, before going into this, like my experience in SVC, let me just go through, like as a student, how you guys are feeling now. You may have a kind of an anxiety. I can see a lot of questions on the side. People are asking, I am weak in geometry. Is there any business opportunity, etc., etc. To be put it point blank, as discussed by our experts here, First, you should have the problem solving ability, be it whatever engineer you are, number one. And second is you should have the aptitude for learning new things. Whatever stage of your career, be you are a head of the department or you're just an entry in a trainee. So you should have that acumen, or you should have the drive to learn, because every day you're learning something new from someone, maybe your peers, your colleagues, your juniors or seniors. So that is very important. You should have as a trait in yourself to learn, to solve the problems. And some of them are even asking like what kind of softwares you should learn. There are a lot of softwares in the industry. Like it depends on the industry which you are going, like maybe sugar industry or hydrocarbon industry or mining industry. A lot of industries have their own softwares. And what is a software is only 1 + 1 is 2. If you know the answer, yes, it's right. If you don't know the answer, whatever answer is given, you have to. So what I'm trying to say here is learning software is not important. Learning the concepts is very important. What you do in these 4 years is more important than anything you do afterwards as an industry expert. These 4 years, the basic fundamentals, the definitions, as Professor Pushpanam sir has highlighted, the basics, the fundamentals you've learned in your college, that comes really far into your career, like taking you to address the problem solving. Say, for example, you want to compress a gas. You're saying that I can apply pressure, I can compress it. No, beyond, if you don't reduce the temperature below the critical temperature, any amount of pressure cannot compress it. So these definitions, this comes in handy when you learn the concepts well. Without concepts, I don't think so. Like you are not building a strong foundation for your engineering course as such. And I can see a lot of people are saying like, what can I do this way? I would say simply put it point blank. You have to develop your own interests. And chemical engineering is one such fascinating subject wherein you have it is interdisciplinary, wherein you can learn a lot about maths, you can learn about physics, you can learn about chemistry, you can learn about mechanical engineering, say solid mechanics, fluid mechanics. A lot of subjects are composed into this chemical engineering that makes you really industry ready, be it from sugar to paper pulp to oil and gas to mining, etc., etc. So I believe this 4-year course in SVCE had a lasting impact on me. I did not go for any other coaching. I did not take any other softwares for that matter, to be frank. And Professor Dr. N. Mayappan, he was my faculty advisor. So it's like class teacher in school concepts, for you kids. Like if you will say like, it's like my class teacher. So he is my faculty advisor. He has been guiding me through since then. So whenever we have one-to-one interaction, this is something very specific to SVC, I believe. Because like what I can find is like we were having the liberty to go and ask him and get our doubts cleared. And thus such faculty advisor to student interaction is very, very critical to get guidance here. And I believe in SVCE, I had the privilege of getting associated with Dr. N. Mayappan, and he has been guiding me through. Recently, also 3 months back, I called him for one of my projects where we needed the conceptual design was going on, like which kind of mills to be chosen for, like say a wet ball mill or a dry ball mill. No, he was the only person I'll immediately fall back to. So such kind of faculty advisor guidance and the kind of resources available in the college, and these things have really helped us in learning. Like what happens is like there used to be kind of syllabus, there used to be kind of syllabus saying that this is the thing you have to learn. But what we were taught is not the syllabus concepts. Like what is the conceptual clarity you get? The conceptual clarity helps you to solve the problems. And this conceptual clarity is a must in engineering, be it whatever engineering stream you're taking in. This conceptual clarity, which was imparted as part of our 4-year curriculum, is something which I still look into even today. So oil and gas or any industry for that matter, you take all the concepts from your 4-year engineering, simple, point blank. Once you are through with this, then you have a lot of opportunities because you have gained the knowledge. and knowledge is power. Once you know the conceptual clarity is there, and then the college offers even the opportunity to develop yourself, personality development, and a lot of opportunities are provided by the college to develop yourself as an engineer. From a graduate to an engineer, there is a transition. Not all graduates are engineers, no. Once you have to gain that conceptual clarity, then only you become the engineer. Otherwise, you are just a degree holder. This is what the problem is about in Indian scenario. People are not industry ready. What do you mean by industry ready? People are thinking that you need to have a lot of software courses to be done. No, absolutely no. You should know the concepts well. If someone asks you something in the interview, you should be able to answer the interview. See, nowadays I am in the public sector. I am in a public sector undertaking, Engineers India Limited, part of MOPNG. There are a lot of public sector companies also are there, like ONGC, IOCL. These companies are also recruiting. So what do? They have the GATE exams, and these GATE exams is all about conceptual clarity. So this kind of conceptual clarity is essential in essence to become an engineer as such. And coming to the slide, the part like you will have a fantastic faculty here. You know, they help you out with the basic fundamentals. Starting, you will be handheld and taken up. You know, the conceptual clarity, the access to books and other resources, furnished labs and supportive staff, the faculty advisor inputs. These are all very critical in your shaping of your career in the next 4 years. And the choice of SVC as such, I would say, the choice of SVC matters a lot. And if you are in SVC, you stand a better chance to become a better engineer because of the facilities and kind of faculty provided here. And I have taken the benefit of such facilities, and today I am here. So I joined EIL in 2008 after fresh from college. After writing an all India exams, I did not go to any other coaching. I did not do any other coaching apart from just studying in SVC. Only the conceptual clarity, that's it. Once the concepts are clear, I had passed through the written exam, I passed through the interview also, and then I'm currently posted in Delhi. It's been 12 years, and the journey has been fantastic till date. I'm learning every day. I'm you know, this learning and aptitude for learning and creative thinking, out of the box problem solving, these are the essential traits as an individual you should possess and you should develop to become a successful engineer. With these words, I thank everyone who have provided me the opportunity to speak. I am not a good speaker as such, to be frank. I think I have not missed any points. I suppose I have given the best here. Thank you for listening.
Thanks, Santosh. It was wonderful. It was wonderful for sharing your experience and suggestions to young minds. Thanks. Now let me introduce other dear alumni, Ms. Bhuvaneshwari, who is serving as a project manager at Shell Bengaluru. She has completed her BTech Chemical Engineering from SVC in 2008 and later completed her MS from Technical University Delft, Netherlands in 2012. She started her career as a technologist, downstream manufacturing chemicals in Shell, Amsterdam. In 2015, she moved to India as category analyst in Shell Bengaluru and currently serving as a project manager. Her expertise includes energy modeling of renewable energy forms, integrated energy solutions and energy optimization, cost modeling and techno-commercial, cost proposal developments, commercial levers for contracts, market intelligence, industry research and benchmarking, providing external proof points and actionable insights, supply chain management and transformation, strategy planning and analysis. Hi Bhuvaneshwari, I welcome you to share your career pathway through chemical engineering at SVC to our participants. Bhuvaneshwari, yeah.
Thank you very much.
Yeah.
Welcome,
Yeah,
Bhuvaneshwari.
thank you
Please.
very much, Professor Nalikant. Thank you. Am I audible just to test?
Yes, you are audible. You can present your
Okay.
slides.
My network is
Okay.
a little bad here, so I'm going to go off
Okay.
video. Let me see if the this will help. Yeah. Okay. So thank you very much, first of all, for this wonderful opportunity. I think I have never done this. Nobody had done this also for us. I think one of the very, very privileged aspirations or auspicious occasion here to me for me to be able to share my experiences and a little bit about the alumni experience, because like you say, I think many industry experts in the past spoken about what is on board or what is ahead of the journey for chemical engineers. But I just want a moment to reflect a little bit about my own personal journey and how I have landed here. That might be an inspiration for others to come. So I don't have much to present. I am just going to put up only one slide that I have here. Let me just share my screen.
Okay.
Can you all see my screen?
I was waiting for it actually. It's not appearing, Bhuvaneshwari.
Okay, one second. Let me try again.
Can I check? Okay,
Yes.
try it.
Let me try this once, and if it doesn't,
Sometimes
then
it
maybe.
may present your entire screen and then you can open the PPT and then do that.
Correct. Yeah, that's what I'm doing now.
Yeah, it's coming.
Can you see
It's coming.
my
It's coming.
screen?
Okay.
Okay.
It's coming. Yeah.
Good. Yeah. Okay. Thank you. So basically, what I did was, out of my interest for basic engineering, like we say, like chemical, electrical, mechanical, industrial engineering, etc. I really was driven by my choice after I finished my 12th in Chennai, and that is why I decided to proceed with chemical engineering, because one of the previous speakers mentioned, I was wrongly oriented because I had a very deep liking for organic chemistry at that point when I finished my 12th. However, it was only to my surprise that after I took chemical engineering, I realized that engineering is a completely different ballgame altogether. It is not your basic, what do you call, sciences. However, it's a much advanced and much more to understand, for you to gain very deep insights into how to even build something that can operate, or how to troubleshoot something like a plant that is standing right in front of you. And that is what I think SVCE taught me, the pride that I can say that hands-on application of converting your concepts into real-time skills. That was one of the biggest learning opportunities for me. Thank you to the entire team. I think Santosh and myself, classmates, in fact, to be precise, and we have gone through the same journey with Professor Mayappan and many others also in this call. So that is one of the starting points for me. But after that, what I did was, as an opportunity that I obtained because of the placement after I finished my engineering in Venkateshwara College of Engineering, there was a opportunity, and they had brought in Frost & Sullivan, a consulting company, and because of the interest that I had in chemicals and materials, I joined that company for a very brief period of time. As soon as I joined there, that was my first exposure to industry, what an industry is. Now, all your studying, the 4 years that you gained, how much ever you study, it is really not possible for you to bridge the gap between academics and industry. And immediately when the industry experience struck me, I wanted to propel myself in the direction of specializing further to studies, further studies and master studies. And that was exactly what I did by joining the Delft University of Technology in the Netherlands. And that was a specialization in sustainable energy technology studies, mainly focusing on solar, because I was pretty much driven. I looked at the industry trends. I looked at how the industry will be moving in another coming 20, 30 years, and how the energy industry overall will evolve. That was my background for leading myself to go abroad and study there. And as soon as I went to Netherlands, I think it was a completely different experience, because the minute you step out of India, and especially to a different country, your opportunities are pretty much going to be shaped by what you make of them. Like I think even a couple of others were pointing out in the past. Of course, I had my solid basics with me, which were the concepts that I gained, thanks to SVCE for that. And after that, it was an eye-opener for me, where I really started working on a lot of skills, like, a lot of other life skills, so to say, such as, problem solving. How do you solve when you are having a real life situation as a problem, even at the time of studying? So in the Netherlands, they are very critical about how a degree is offered or a thesis is being conducted. You need to do a lot of research, and you have to prove to the entire team or the department that you are actually worthy of something that they can award you a degree with. So that is when my critical problem solving, emotional intelligence, and application of whatever I have learned really came into picture. I started asking a lot of whys, and that is when I really learned how the world will operate as far as application is concerned. And I think many of the skills that I would like to point out are, some things that SVC really taught me, because they give you the first opportunity to explore the teamwork. That is when we, as a couple of students, we explored the concept building as in-plant training. We got the industrial exposure to do a real-time project. We did a project in Chennai Petroleum Corporation Limited. That was our thesis project. That is when you can start applying your critical skills, and how do you really evaluate yourself as to whether your concepts are clear to you or not. That was my first eye-opener to the world, to be very precise and honest. And then the minute I graduated out of Netherlands in specializing in solar technology, I built a prototype where for street lighting applications, instead of solar panels, I constructed, at that point in time, solar cells were much still very expensive. So I wanted to replace the panel with something like a plastic material with a dye that is injected in it. So of course, I had to use all my chemical engineering concepts, all mathematics, all physics, and like many others pointed out, there are interlinkages to multiple areas where, you will have to bring those together. You will have to marry one discipline to the other, apply those, and finally, that is what I was able to develop for Philips as a thesis research project or a prototype. I was able to demonstrate to the world that yes, this will work in terms of your efficiency, very equivalent to that of a solar panel. And of course, it was at that point in time at least 40 to 50% cheaper. So further, I finished that, and after that, I was again looking out for opportunities where I can really apply my energy studies at that point more to an industrial level. And that is when I came across opening in this global company called Shell. That is when I found this, that there were vacancies and they were taking people with a process engineering or a solid process engineering background. Of course, my first preference at that point in time, because I graduated with a master's in sustainable energy technology, I asked the company why they even to interview for energy technology options. Like I can imagine at that point in time, the alternative energy did not pick up as much as the necessity is. So they told me, you have a chemical process engineering solid background, because your skills will be very applicable, very useful to us, either in the upstream business or in the downstream side of the business. And as a company, that gave me the opportunity to evolve from one role into another, because the company policy itself is primarily based on job rotation. They do not of people doing one job for 3 or 4 years. So I do not know if it was a lucky choice or an unlucky selection, but I got myself into the process engineering role. And then I started as the first, started out in a graduate engineer. So that is when, like Santosh was mentioning, how do you manage to go from a person who has matriculated with a degree in chemical engineering to really grooming yourself as a graduate that will enter into an industrial experience. So that was my first opportunity, where I got into a program, which is called the Shell Graduate Program. They developed that program, and even the selection process for that program was extremely rigorous. They go to the extent of testing your capacity. They go to the extent of testing what your achievements are, what your skill sets are, how technically sound you are in concepts, and the most important aspect, which is relationships. Because in the industrial world, I think many of the others have also pointed out, stakeholder management, communities, linkages with how sustainable you are as a community, the confidence others have in you and your product is absolute paramount importance in the actual world. So that is when I graduated from a person with just a degree to a person who can really work for an industrial company such as Shell. So that was my first experience. I started in chemicals. I started in chemical technology. That is when, like many of the others were pointing out, I had the opportunity to work on debottlenecking projects where I had to troubleshoot, I had to increase the capacity of a live operating plant in the Netherlands. And apart from that, there were critical decisions that were supposed to be made. So you play the role of multiple person. You not only play the role of a process engineer because you design and you make your decisions based on that. However, you're also taking the decision of whether this will allow me to go to that extent of capex investment. Will this really be working for me in terms of opex investments? What does this mean for the future? If I do this, what does this mean for the future? Those are the critical questions that I was exposed to, and I think I was very lucky because honestly I had a lot of people who helped me gain on the job experience. I think that is my paramount stressor for this this webinar, because on the job experience and on the job training is something that cannot be replaced. That is irreplaceable, simply put. So that is one where you gain a lot of exposure. Your thinking actually is shaped because you're talking to people with multiple exposures, multiple experiences, and that will obviously change the way you want to develop into, or what do you want to get out of the job that you're doing. So that was one of my biggest game changers, actually speaking. And further to that, just because of the job rotation policy in Shell that is naturally existing, I took an opportunity and I wanted to move to India to see. They were setting up a Shell Technology Center in Bangalore. They were actually expanding the center. It is existing for quite a while now, but they called it the Projects and Technology Center in Shell in Bangalore. And they were looking for people who can come back and who can actually help develop this as a concept center. So that is when I moved back, and then I did a slightly different role. So I did a role of something like selling the chemical that I was actually helping to design or helping to produce and helping to troubleshoot. So that was the other end of the spectrum where I wanted to see how the markets are evolving, how your appetite in the market is existing for this chemical. How do you balance supply and demand in terms of if there are no opportunities for you to sell a chemical in a landlocked market, then what do you do? Those are the kind of things that I started gaining, I started doing. That is when I got a very deep interest into understanding the existing contracts that we have with third parties and multiple other companies. And a contract deep dive, a cost rigorous analysis, a consulting kind of an outfit, those are all really things that I picked up and to make the company as one of the most competitive company in the supply chain. So that was a very, very enriching experience, I would say. And now with gaining something like a commercial or deep commercial, I wouldn't say deep, but at least a brief into commercial experience and a very significant technological role, I've started evolving myself as this techno-commercial person, because now currently I am doing the role of a project engineer and project manager. We have multiple technologies in Shell in both downstream and the upstream divisions, and we are selling the technology as a licensed package itself for our third parties. So that is where I am involving. I'm involved quite a bit. I'm working with the EPCs, the front-end engineering design companies, and also many of our clients, such as the biggies that you named, that is the Abu Dhabi National Oil Company, the Indian company, in fact, Indian Oil Corporation, and it's a real opportunity where you're talking about controlling the schedule, controlling the cost, controlling the budget, and ensuring that your project is actually meeting the objectives that the company or the client has set out for. So that's my current role. Now, overall, this has been my journey so far. Now, let me take one step back. I think I've also been seeing the questions that people are asking. I'm weak in geometry. Do you think I can do this? I am, what are the software skills that we need to be gained? So my basic answer, just like how Santosh was mentioning, was you need the confidence. You need your confidence to be absolutely strong, impeccably strong. That is what SVCE will really help you, propel you, provide the correct infrastructure for you to be able to gain that, and that is your starting point. After that, please understand that this is more like a 4-year journey, after which your career literally is going to start. Now, to ensure that you start off your career, there are basics which you need to anyway fulfill and obtain, and absolutely after that, how you zoom past is up to you. You are your own the responsible person to ensure what your interests are, propel yourself in those directions. Sometimes life skills are the ones that are absolutely necessary, which is really not possible for you to be taking off a textbook. And I think SVCE really does a brilliant job of that, because these life skills I got introduced to right at the beginning. Like I told you, industrial exposure. Like I told you, how to deal with stakeholders, how to deal with people who do not encourage you so much, how to deal with obstacles, how do you really solve problems, how do you solve problems in real life. Those are the things which you get early on exposed to. And one of my biggest strengths, I think I would like to really congratulate, or rather give credit to SVCE, was for bringing the confidence in me, for bringing, in fact, for encouraging and at the same time providing of that loop so that I can positively bring out my communication skills to the forefront. Those are the kind of things which are required for any kind of role, any kind of job that you do in the current scenario. And I think the younger generation is just going to become more and more aware, more and more necessary to pick up those skills. And that is exactly what SVCE can be a game changer too. And of course, let's not forget, beyond all of this, there is something called, once you end something, there is something called on-the-job training. So that is irreplaceable, like I mentioned. So this is my short, summary of what I picked up and how it can be helpful for others who are really interested in picking up this as well. Thank you, everyone.
Thanks, Ms.
Thank
Bhuvanesh.
you.
It was a wonderful presentation. You actually made us proud, actually. We're happy to hear that SVC has installed that confidence to pursue a career in chemical engineering. So some people have some the thoughts. I'm a girl. Can I pursue a chemical engineering? Working in industries is possible or not? So you are a classical example or a very good reference where our students can take confidence and they can pursue chemical engineering career. Okay, thanks, Bhuvaneshwari. So now
Thank
I
you.
welcome Professor N. Mayappan, Head of the Department of Chemical Engineering, to brief about chemical engineering program at SVC. Sir, you can
Yes,
proceed.
please. Yeah,
You want you?
yeah,
It's
slides
how
are,
it's visible, sir. Yeah, you can go ahead.
yeah.
Yeah,
Okay, thank you. Thank you all. Let me present about our department. This pathway is happening from 29th of June to 18th July. We got a turn today to brief about our department. It is about the realizing the future with reactions. Realize the future with reactions. Yes, we Department of Chemical Engineering have undergraduate program BTech Chemical Engineering, postgraduate program MTech Chemical Engineering, and we have PhD program. We have a Center for Research. The
so the
program
presentation came out, I think. Can you just PPT? Yeah.
PPT.
Yeah, it's okay. Okay, sir. Yeah, good.
Okay.
Thanks. Yeah.
That's fine. The department is started in the year 1994 with an intake of 60. Currently, we have 120 intake. It is in India accredited since 2003. This undergraduate curriculum focuses towards the next generation technologies. Can you ask all of them to
Yes,
put
yes.
mute?
Yeah, please mute
Some
Mr.
disturbance
Surya
is there.
Ravichandran, and you can mute Surya Ravichandran.
Yes, sir.
Yeah. Most of them are muted actually. Yeah. This one.
Muted,
Yeah, yeah.
let me-
Surya Ravichandran, are you there? Can you please mute? Yes. Okay. Leave it, sir.
Okay.
Yeah.
Our undergraduate program focuses towards the next generation technologies, and our MTech program focuses towards the revolutionary technology. And we have a Center for Research since 2011. Let me tell about our faculty strength. We are 20 in number. Out of that, 10 of us are with PhD. One-fourth of our faculty members are pursuing PhD, and remaining are about to start their PhD. They are with masters. Let me tell about the curriculum and the co-curricular activities. Curriculum, currently we have choice-based grade system. This curriculum is well exposed to, as it was briefed by the earlier industry expert as well as by the professor from IIT, and as well as it is now we have only 37% exact core. Professional core is only 37 to 40%. The remaining all distributed among the basic engineering, engineering science, humanities science. We have nowadays in this curriculum we have professional elective. 6 professional electives are there, and we have 2 open electives. Open electives which directly goes to other departments. Other department electives they used to study. They study in other programs, especially marine engineering, computer science. They will take up the knowledge from the other programs. So now it is well distributed. Coming to the co-curricular activities, students can very well take up the courses, value-added courses. Certainly, they are permitted to have special electives, value-added courses, and they are allowed to have some training, additional training. It has all been exposed. Value-added courses are handled by our faculty members. We have a mandatory course. All these things, value-added courses, either they can have in class, direct contact, or they can have in the online courses. Then we are also exposed to guest lectures. Every month, at least one guest lecture we will be having, and we also expose them for having. We also conduct a national level symposium. Fan survey is conducted every year, and we also have conferences. At least 1 or 2 conferences and workshop, minimum one in a semester we used to conduct. Then in-plant training and visits and internships are offered. Now in this curriculum, in-plant training is a must. Everybody is supposed to do an in-plant training. Internships are also taken by most of the students, and it is also facilitated. Summer internships are there and winter internships are there. Most of the students get engaged to that. And nowadays, not only the theoretical project, now all of the students are encouraged to do practical, research-oriented projects. The 8 semester project, they take it very serious and they do some kind of innovations and they do it. Not only that, they are also allowed to do some prototyping of small scales. They can do it, and which can be scaled up. That level they used to do it. Then we have professional societies. We have Indian Institute of Chemical Engineers from way back. Way back we have from 2000 onwards we used to have, from the second batch onwards it is there. It was inaugurated by Professor G.S. Lada, the very well-known director in Anna University, ACTech. It was inaugurated by him in SVCE. We have Engineers Without Borders. Recently, from the last year, we have American Institute of Chemical Engineers. That professional society also we are right now operating. All our students are AACHE members. And we have IST, Indian Society for Technical Engineers, and we have the Institution of Engineers, and we have the ISTD too. We have bagged Best Student Chapter Award several times. 11 times we have bagged. In that, 7 times we bagged this Ambuja's Best Student Chapter Award. In the years, for 4 times we have bagged Pidilite Industries Best Student Chapter Award. Some of the professional activities which has happened in this year, it is being shown to you all. The first one you can see. The guest speaker, today's speaker, Sri Masla Mani, the head of engineering from INSYS, is clarifying a doubt to our student. And this is another guest lecture by the Madras University professor. And this is our core team. Our team our association team members. One second. Okay. This is the members. Our association was inaugurated by Mr. Arish, who is serving in FL Smith. The gentleman came here, and we have the general manager. First time we have conducted a memorial lecture by IICHE Chennai Regional Center (CRC). The guest was the general manager R&D, who came here and delivered from CPCL, and this gentleman is Sri K. Ilaya Perumal, who served in ISRO and got retired, and he was there with us. He delivered the talk. And this is Mr. Sandal Kumar from INJES. He came and delivered a talk along with Mr. Maslamani when they came for MOU. And this is our infrastructure. When you look at the infrastructure here, this is our chemical reaction engineering lab, which is also facilitated with the support of MODROPS. And this is our fluid mechanics lab, and this is our heat transfer lab. And we have a very big unit operations lab, and we have a process control lab. Our process control is a very unique. We have distributed control system. This distributed control system is very unique, and we have similar to, we have pressure controller, level controller, flow controller, temperature controller, all the controls as they do in the industry. Similar way we also operate and we demonstrate to our students. And we have a well-equipped, sophisticated instruments lab. Instrument method of analysis, IMA lab, we have most of the instruments for analysis. And then that is VGC, gas chromatography, AAS, atomic absorption spectroscopy. All these equipments are there. And most of our returns lab equipments are with data logging facility. We have data logging facility. Very much it is being interfaced with the data logging facility. And we have all this returns lab is also supported by MODROPS. And our process modeling and simulation lab has all the softwares. We have Aspen software for 150 user license, and we have ProSim software, and we have MATLAB, we have ANSYS Fluent software, and we have all these softwares are available, and we make use of the software. And currently we have a course process modeling and simulation. And we have industry, very good industry institute interaction. Every year we used to conduct in the institute interaction meeting, III meeting we used to conduct. Industry institute interaction meeting is always there. Every year, every academic year we used to conduct one meeting. And we have a MOU with these industries. Our department is having MOU with SPIC, our chairman. And all the industries, whatever they have, we have an MOU with them. Manali Petrochemicals, Tamil Nadu Petro Products, and with ABAN Research Center, we have ABAN Infrastructures. We have Malkolak Knowledge Center, Weekend Boyo, Tirumala Chemicals. With them, we have a consultancy. And with the Psychospectrum, we have. And recently, we have, this year, we have made a MOU with INJES. And we have done a consultancy with them. That consultant, that is recent MOU is being shown. Our principal are is displaying the MOU agreement with the managing director of INJES. And Sri Maslamani is also seen there. Our placement officer, all are here. And our students recently visited TPL. The TPL display is there. And one section of students have visited the TPL. And this is another section of students visited MPL. And our students are doing internships in the factory. A group of students are all senior doing internship. Students' accolades, very few accolades has been shown, very few things which are very predominant, important, we are displaying over here. One of our student with the internship, with the stipend of 80,000 rupees, she has visited Yoshi, Japan. She is senior, and she Ananya Ravi, and she is undergoing a class there. And it is our students have taken a hackathon win over there in the VIT. Vellore recently, all our students have gone there. Most of our final year students are senior, and they have got recently. Our students have gone to SN College of Engineering and bagged places over there, secured places over there in SN College of Engineering. Our students are senior. Deepika and Our predominant alumni is, you can see the predominant alumni is here. Alumni is Dr. Bendu Madhavan from 1994-98 batch. He is a senior principal scientist in Switzerland. Satish Narayanan is serving in Intel Corporation. Sivarajan is serving in Central Leather Research Institute CLRI. And Ganesh is serving as Group Vice President in Yes Bank. And Srividya, she is serving in International Business School in Singapore. Perumal Arubagam is serving in Climate Change Secretariat. He is serving there. Sandhya Sundaram from 1988 to 2002 batch. She is in Shell, Texas. Sivasubramanian is a Chief Information Officer from VA Tech Webac, Chennai. Vasant Emmanuel is a CEO at FR8. It is a company which deals with the trading. Then again, we have Lavanya Ramasubramanian. She is an environmental engineer in Philadelphia. And we have Ravichandran Rajendran. He is a principal engineer in Technip, Chennai. And we have Madhu Smith from, she is serving as a director at Koyak Technologies Private Limited, Pune. And we have the alumni. Some more alumni like Vignesh Pichaya, Rajesh M. Abraham Sheikh Moses is a director from Hubert Enviro Care Systems. We have Rajesh Ravindran, who is serving in Netherlands as process engineer. He is a later entry student. He also passed out with a good rank, university rank. S. Deepak Kumar. Paul Rajan is serving as a process engineer in Nuclear Power Corporation, Kodangulam. Some more students are also there in Kodangulam. And we have Dr. Michael Miranda. These people are doing research. Most of them are doing research. Dr. Michael Miranda, he is doing his postdoctoral fellow. Currently, he is pursuing his postdoctoral fellow at Ohio. And we have BJ Aishwarya from 2007 to 2011. She is a process engineer at Dow, Qatar, Dow Chemicals. Dr. Anita Ravikrishnan, she is a scientist at Tissue Engineering, San Francisco. Dr. Karthik Subramaniam Pushpavanam, today's speaker's elder son. He is a postdoctoral associate at Arizona State University. We have Ishwara Narayanan from 2009 to 2013. He is serving in Cipla, Greater New York City. Raj Kumar is serving as Managing Director, Solo Paints Private Limited. And we have Jyoti Prakash, who is serving in McDonald International Incorporated, Chennai. And we have Swaminathan Tyagarajan serving in Gujarat in Nayara Energy Private Limited, Jamnagar. And we have Priyavadana, who is the Assistant Inspector of Factories. Most of our students are also serving in Pollution Control Board. She is serving in Tamil Nadu Factory Services. She is Assistant Inspector of Factories. Recently graduated from 2016. She is there. We have Brownie from 2017. She is serving in Vedanta Resources. And we have Anjana Murali. She is also serving as Senior Engineer Lead Operations from Vedanta Electro Steels Limited. Shreya Naresh is also serving in Vedanta, Udaipur. Some of our placement, our students got core company placements are being displayed over here. Vedanta, PIC, Trosix, FL Smith, Technip, Tamil Nadu Petro Products Limited, Manali Petrochemicals, Petrofac, Tirumali Chemicals Limited. A good amount of students are serving in Tirumali Chemicals. Ranipet, nearly one section of students. 150 students are being placed in Tirumali Chemicals, Ranipet, Nippon Paints, Asian Paints, Saipem, Saint Gobain, Dow, Thermax, the India Cements Limited, Nagarjuna, Kins Engineers and Constructors, Archian, Siminfo Systems. Siminfo Systems is director is son also studied here. W. Raman's son, Guru Prasad, studied here. And we have Parla Agro. Parla Agro is very near to us. Some students are serving there. Ramco Cements. And some of the opportunities in public sector companies are, we have IOCL, BPCL, HPCL, ONGC, SAIL, GAIL, FACT, MFL, PHEL, CP, NLC, Indira Gandhi Center for Atomic Research, Kalpakam, DRC, DRDO, Tamil Nadu Pollution Control Board, CPCL, CPC, that is Central Pollution Control Board. Our students are taking up the opportunities in these public sectors. Before going to the higher education, let me also tell you about the other industries. Industries where they can be public. Some more units are there. Baba Atomic Research Center, Nuclear Power Corporation, Atomic Energy Regulatory Board, Uranium Corporation of India, Electronics Corporation of India, Indian Space ISRO, DRDO, and then we have Bhavani, that is the Bharatiya Nabia Vidyut Nigam Limited, NLC, Naval Lignite Corporation. These are the places where our students can get the opportunities. Not only that, some more core companies. Some more core companies we have. Some more core companies, let me list. Specialty chemicals, Deepak Nitrate, Aarti Industries, Vinati Organics, and pharmaceuticals, Dr. Reddy, Cipla, Cadila, Lupin, Sun Pharma, Aurobindo, Pickle Pharma, Biocon, Petroleum, SR, Praj Industries, Reliance Industries Limited, RIL, Shell, fast moving consumer goods. IT, these are the familiar companies where you can get used. Industry Limited, Coca-Cola. Coca-Cola is also having a plant in Chennai. Some few students have done projects over there. Metals, Aluminium, Hindustan Aluminium Company, Sterlite, Hindustan Zinc, Saint Gobain. And also we have companies in product design. That is, then again, these are the places our students are pursuing their higher education. They are pursuing their higher education. These are the few universities. Let me list. NAS Singapore, Clemson University, Georgia Tech, University Hamburg, Delft, Arizona State University, the University of Utah, Riverside, Hamburg University of Technology, University of North Florida, University of Toronto, University of Alberta, Northeast University, University of Pennsylvania, University of Delaware. These are University of Minnesota. All these places our students have got the opportunity to study. These are the places they are pursuing. In national level, we have UDCT. In UDCT, very familiar with the Indian technology, UDCT and IIT Bombay, IIT Delhi. Our students are also masters in BIM, IIM Ahmedabad, University of Petroleum Energy Studies, Dehradun, and we have IIM Trichy. All these places our students are doing in national level. IIT Madras, IISc Bangalore, IIT Roorkee. These places our students are pursuing. Annamala University, all these places. Let me tell about our chemical engineering will imprint your desires, predefined path to destination, which will make you known to unknown. Always start with, which will make us, let's not the discipline be the barrier. Discipline is not a barrier. Then again, we would like to very clearly and make a firm decision. Everything around us is chemical engineering. So experience it, explain it, excel in your goals. Then there are so many, plenty of opportunities. Let me put like this. Knowledge, that is knowledge plus attitude plus skill. All these things are equal to, with the support of SVCE, we will land up in the success. When there's a good amount of knowledge plus attitude plus skill, all these three things will equate you to success. For further details, you can visit our college site and the department. Thank you. Thank you, Nalan. We can take up the question answers.
Yes. Okay. Thanks, sir. Thanks a lot for your information. Just to add some more information to that,
Please add.
if you are motivated to do research, so I would like to add that our department, our department has nearly close to 2 crores rupees worth of funding for doing research. Okay, so we have a very advanced process control lab and a nanotechnology lab and a CTS sponsored computational simulation lab. We have several softwares also which students can practice. so that
Yes.
they can be industry ready and then they can get directly a design engineering jobs. And and I would like to tell for the students, we have many scholarships. Some of the scholarships, sometimes you get a
Yes.
tuition
Yes.
fees waiver, like meritorious academic performance. Merit come means economic means scholarship, performance in sports and NCC activities are being provided. Those scholarships are provided. And we also provide prizes for first ranks in the test examination. So you perform better, you get always that incentive and the benefit you are getting it. And our department also provides assistance for book and instruments. And and for successful, if you perform in your BTech program or MTech program and chemical engineering successfully, we also give awards, several exclusive awards for chemical engineering students, like Sri
ISN
Harihara
award.
Sudan Educational Trust Award, Dubashi Balakrishna Dora Award, Budding Bright Engineers Award. And our chemical engineers are also eligible for receiving college level awards such as Devagi Mutaya Endowment Award, Panikar Award, Outstanding Sports Person Award, Outstanding NCC Cadet Award, Best Student Award. And one thing which I would like to stress is, if you look at our history, till 2018, before we become autonomous, up to that, we have bagged the university rank holders consistently the top first and second rank, right from 1998 to 2001, 2002, 2003, 2006, 2007, 2009. So like that, we are consistently bagged the university rank holders, top 1, 2, and 3. So this is just to highlight about the student achievements. And just to add more that the facilities here and the faculties here are very well versed. And we have attracted a foreign student also. His name is
Yes.
Mr. Himanshu Dashora from US. He visited our department through his Fulbright scholarship, and he did his research work over there. And then he was in our department for 9 months. So
10
he's a
lakh award.
visiting research student. Yes.
Yes.
So these are some of the highlights of the department. And I would like to present you a small short video, and then with that, let's just look into a small video. So
The 30 seconds
okay,
video.
so just 1 sec, 20 seconds only. Yeah, nothing happened there. Okay, so I would like to about.
Yeah.
Okay, is it coming?
Yeah, yeah, it's coming. It's our campus, our lab, our e-trans lab.
Okay, thanks. Just that was to summarize. So before we go for Q&A session, I would like to call upon our just passed out student, or Miss Yagna Madhavan. Actually, she's waiting for graduation because of this COVID pandemic. It's being delayed. So she will brief about how she has explored opportunity through chemical engineering at SVC. He has just finished. She's just passed out from
Yeah.
this year. Yagna, are you there?
Yes, sir. I'm here, sir.
Yes. Yagna,
Can I
welcome,
switch?
Yagna.
Yeah,
Yes.
Good
welcome.
morning,
So,
sir.
yeah, can you
Well,
briefly talk about how you have explored, what are the various opportunities, how SVC have shaped and your
Sure,
4 years
sir.
stay here? Yeah,
Sure, sir.
let me,
Sir,
yeah,
yeah.
stop. I'll stop presenting. Yeah, you can switch on your video and you can talk
Okay.
if it's possible. Yeah,
Okay, sir. Am I visible, sir?
yeah,
yeah, you're visible.
you're visible.
Okay. Thank you, sir. So good afternoon, everyone. I'm Yagna Madhavan, and I'm a final year student in the Department of Chemical Engineering. First of all, I'm really happy that the college and the department gave me an opportunity to share my thoughts of being an SE. So initially, to begin with, I was very naive in my starting years. But now, when I look back at these 4 years, I could tell with conviction that the opportunities that I realized while being here truly instilled a confidence in me. Because the college and the department offers ample opportunities for you, and that will bring out the inherent potential in you. So, with respect to my time here, one such was the internship that I received, which was offered by IIT Madras, and that was done under the guidance of an able guidance of an IIT professor, and it was truly a life-changing experience. And my project was basically a study on water harvesting from rain and other natural resources in Uttarakhand, and specifically in a rural area. So there I could see how my classroom learning on water harvesting methods, let's say like water management, came into practicality in a rural area. And this couldn't have been possible if not for the initiative that the college and the department took to collaborate with the IIT alumni group, the PALS group. And second thing would be, I also got the opportunity to exhibit my leadership skills when I was selected to the post of the joint secretary in my pre-final year. I truly cherished that time because I learned about teamwork, organizational skills while coordinating college-related activities. And at the same time, I felt like a representative of students' opinion because I was able to convey their opinion and the feedback to the teachers, to the faculty, and to the heads of the departments. Now, through this, what I realized was being here in this college, there was a two-way communication that existed. So it was not just about just the faculty informing students, but rather taking their feedback as well. And that was also done through the class committee meetings that we used to have every semester. So at the end of the day, I would just like to tell that SVCE will equip you with the skills to build a career, but that will not just be confined to getting placed or getting an admit into higher universities abroad or India. Because yes, with respect to placements and universities, there are student development activities because there is placement training that is being given to students from all the years. And at the same time, there is this event called the mock placements, which is a very exclusive event, and that is conducted for the pre-final year students. Because if you take mock placements, there is actually a mock aptitude test, a mock GD session, and a mock interview that is conducted by a HR manager, where HR managers of different companies come and they interview students, and also they give you the feedback. So this process will actually give you the confidence, and you will be able to face an actual interview, and you can also see yourself. You can also introspect on how whether you're industry ready or whether you need to work more, or what are the weaknesses that you need to, probably you can do a SWOT analysis on yourself after this mock placements. And apart from this as well, just to broaden your knowledge, we have symposiums, seminars, and workshops where the department invites experts and industrial experts and academicians to interact with students. This happens simultaneously with our class sessions, because that time they will talk to us about industrial trends, the problems that are currently present, and the solutions that we can offer as future engineers once we enter. So that's about it. But apart from that, like I said, it's not just job or an admit, but at the same time, we do have an EPIC cell, which is basically the Entrepreneurship Promotion Incubation Center. This cell encourages students to integrate their technical skills and innovation into product building, because they have the facility and the resources, and they will be able to provide the right guidance to the students who are interested in taking up or in putting your technical knowledge into into having a startup or into product building. And this, of course, it will come. This of course will enrich your knowledge into in the stream which you've taken. And at the same time, the seminars and workshops will also give you this information where you'll be able to narrow down your interest so that you can choose a right program for masters. So that's it. But I could just tell that overall, with these 4 years, I had a well-rounded experience, and this could have been possible only because of the college and the department. So with this, I mean, I would like to thank the department and the college for being so supportive through these 4 years. And I guess they have realized my true potential, which is given me the confidence to explore new paths and new ventures. So thank you so much.
You can also tell
Thank,
about your recipient of the award, Panikkar Award. You can tell about that. You are recipient of the Panikkar
Yes,
Award,
sir.
no? You can tell.
The Panikkar Award is usually it caters to the pre-final year students once we are in our third year, and this award it was it kind of like boosted my confidence because it was able to tell that yes, I could multitask and I could balance, and that I guess that will be taught in college as well, because of course once you go out, you will have to multitask, you will have to balance. And so basically this award usually tests your academics, I mean sees how good you are in academics, as well as other extracurricular activities with respect to implant training and internships and um, extracurricular activities, so on and so forth. So based on this, they will assess you. And I was, I guess I equipped myself without my knowledge these 3 years, and I'm just grateful that I was eligible to receive this award.
Thank you, thank you,
thanks,
thank you.
thanks, Egna.
Thank you, sir.
Thanks, Egna. We would like to hear more from you. We want you to achieve more. Okay,
Thank you,
so
sir.
keep us in touch, and then okay. Thank you all.
Definitely, sir.
So yeah,
Thank you
now
so much.
we can have a question and answer session. Okay, so I will read out the questions and who have asked, and then anybody can. I mean, I will also tell the panel members who can address the question accordingly. Okay,
Yeah, yeah, yeah.
so this question is from Mr. Akash, he student Madurai, Miss K. Raghavi, student Pondicherry, Miss Rijita GV, student Chennai, and Siaman Marlecha. They are all asking about, worried about the scope of the course. What is the scope of the course? HOD sir, can you tell? Or
Scope
Pushpavan
of
sir,
the
are you?
course.
Yeah,
Scope of the
Pushpavan sir,
course.
can you? Yeah,
Pushpanand sir is not here right
not
now.
yet. Okay, so
Maybe
Masilamani sir,
scope of
Masilamani
the
sir,
program.
yeah,
Yes, sir.
can you
I'm
just
here. No,
just
scope of
scope
the
of the course? I just
curriculum.
They
want
would like
you
to know
are
the
already
scope, objective.
presented. Yeah,
It's only the scope of the curriculum.
can you talk about the scope of the course, chemical engineering course? That's the question they're
Chemical
asking.
engineering course.
Yeah.
Yeah.
Okay, okay.
The scope.
Typically, yeah, you'll start with your mathematics, physics, and chemistry, and slowly move it into other. As stated earlier, you have to learn about other disciplines as well. So there will be mechanical engineering subjects, there will be civil engineering subjects, and say electrical instrumentation
Electrical.
as well in the first initial 1 or 2 years. Later, you have to, once you go into the hardcore chemical engineering, you'll have to start with thermodynamics, then unit operations, especially dealing with what you call various unit operations which will be used in the industries like separation, distillation, reaction, this kind of things. So each one is called as unit operations. You will learn about all the unit operations which will be used in the industry. Then there will be heat and mass transfer. Like heat transfer about the exchanges, you do the thermal design of the exchanges, mechanical and thermal design of exchanges. Then you get into subjects like corrosion and material selection. Then your subjects on masters like distillation columns and
Sir,
other
Quick
Masilamani
things.
break.
sir,
So
just
these are the basic
Masilamani sir, can you
subjects
cut
that
off the
will.
video and then speak, sir? Can you switch off the video because it is breaking and we are not able to hear you? Yeah, you can speak. So, can you speak, sir? Yeah,
Yeah, you are
yeah,
able to
yeah. We
hear
are
me
able to
now.
hear you, sir. Yes,
Yes, sir.
Is it audible?
yes,
Okay.
sir.
Yes, yes.
So
Audible, sir.
major
Please.
subjects, as I said, unit operations, thermodynamics, then reaction engineering, and then towards kinetics, fluid flow phenomena, then like heat and mass stoichiometry.
Okay.
These are the most important things which will be addressed in the curriculum of chemical engineering.
Okay, sir. Let me summarize it, sir.
Okay.
The scope of the engineering here, what we do is we convert the raw materials into a finished product through the chemical change. This program completely concentrates only in the large scale. It is not chemistry. Chemical engineering is not chemistry. As Professor Pushpan was telling, chemistry is different. Chemical engineering is different. Chemical engineering always concentrate in the large scale. The industrial scale they used to concentrate. So it is the raw material getting converted into a finished product. That is the scope of this course. For that, we used to design. We study the unit operations and unit process.
Yeah.
These are the two major things we used to study. All the unit operations, covering the entire unit operations of the industry, and all the physical changes. Then the process, how does the exact process happening? In kinetics, we used to study the process.
Okay.
That's
So,
the one we have here. Please, next question,
yeah.
please.
Yeah, just so this question is very specific to application of chemical engineering. That's what they're asking. So I'll say that right from traditional, that's what Maslamani sir said, right? Earlier it was only fertilizer industry, and then now petrochemical came up. So from fertilizer, metallurgy, petrochemical, now the chemical engineering is finding application, all these things. Apart from that, you have rubber, you have ceramic, and then you have new industries like biotechnology, industrial biotechnology is coming up, food technology is coming up, and then now cheminformatics. All in all these aspects, chemical engineering is being spread. So the scope is very, very wide. That's what I like to tell. Okay. So the next question is whether engineering is the best course among all other courses. It's asked by Mr. Dinakaran, a student
You can
Salem.
ask our alumni to answer this.
Yeah.
You can ask Santosh to answer. Santosh, please come in line and answer this question.
Whether
Santosh,
engineering.
Santosh, please. Santosh.
Yeah.
Yes,
It's okay, sir.
Santosh.
Yeah,
Please,
Santosh
Santosh
is
is
there.
line. Come
Yeah.
Yes, please. Santosh, please come.
What is the question, sir?
No, whether engineering is the best course among all the courses available. That's the question they're asking. Yeah.
I think this is, like introspection question. Basically, you have to ask yourself, like, what do you want to do, what you want to become. Engineering is always fascinating because I like it. Fascinating. So I find it. It is about like interest, like what on a funny side, if you can say, like if you become an engineer, you can become anything. You can become an entrepreneur, you can become an MBA graduate, you can be, whatever, Tom, Dick and Harry, A to Z, everything under the sun you can become, because engineering such kind of an insights, like application, problem solving. These are all essential skills which you develop in. So engineering is not bad. Whatever choice you want to take in life, engineering really makes your mind sharp. Thinking. So in that front, I say yes, okay. But you should always chase your dreams.
That's nice. That's
Okay.
nice.
I would like to summarize very simply. Science is like a genius. Okay. You can think of any scientist, Ramanujan, Einstein kind of thing. Whereas engineering is smartness. You apply that. You don't spend that much brain to go and find or innovate to find invent something. You take it and then you apply smartly and then you make better use of it. That's what engineering. So if you are this kind of person, then engineering is the best course. And if you're a person who's very inquisitive, then you can look for other science courses. Okay. So the next question is it okay to take masters in US by doing GRE, and how chemical engineering is going to help? This question is asked by Ms. Divya Shivakumar from Chennai. Taking up masters, higher studies. I think Bhuvanesh
Can answer this question?
Yeah.
Alumnus can answer.
Yeah, so specifically, I think to answer this specific question, absolutely, it depends on your interest again. Because once you do the engineering course, then
Pursuing masters.
If you want to spend a little more time in academia, correct, then you can look at specifically pursuing masters. But there is a popular misbelief which I want to really address, because even at the time when I was pursuing masters, everybody kept asking me, why did you not go to the US? Why did you not go to popular destinations like UK? Why did you not study in many other areas? But I think it is also a very important aspect to get out of what you want, because there are many other skills which I was looking for, which I thought would be other countries, and that is one of the specific reasons why I chose to go to the Netherlands in Europe, because in Europe, not just the Netherlands, I think even in Germany to a good extent, the research based and the critical thinking, the way they develop is unparalleled, and it is really not something that you can easily compare with for many other US universities. I mean, many people might disagree with me here, but then what I would like to say is my own personal experience, and please do not be of this opinion that if you go to the higher studies then it will be only US or UK or Australia. It can be any other country as well. Please do your research before you want to go into which direction you want to pursue your master's in, and also equally important will be the country in which you want to pursue your master's.
Okay, that's nice.
That's nice. That well
So like
answered.
that's nice. I would like to add one more point. The fancy, I mean, people say that chemical engineering is queen of engineering, right? So the reason behind that is basically if you want anyone wants to go higher studies, they look for US. And if you look at US engineering school, every program, engineering program will have a definite course on chemical engineering because chemical engineering originated there, and all the universities in the engineering science departments they have chemical engineering by default. So your probability of getting admitted into US universities gets increased if you take a chemical engineering. That is one thing which
That's
must have
nice.
done.
That's nice.
Yeah.
Very much. Very much.
So that's
Yeah.
why people
I
prefer
also.
chemical engineering. That is what I would like to highlight here. Okay.
Yes.
So next question is, sir, HOD sir, this one is for you.
Yes.
On
Yes,
which
please. Yes,
time
please.
class starts and end? Whether the classes will be taken through WhatsApp or any other sources or links. This is asked by Kaushik from Maramalai Nagar, Chennai.
Okay. We start our class from 8:30 onwards, and we will wind up the class by 3:15. But due to this pandemic situation, we are currently operating ourselves in online mode. And
Okay.
always we used to have only in the direct contact,
Direct
person
contact.
to person contact only we used to have, and we used to teach.
Good.
Okay, that's nice.
Okay. So the next question, and yourself and Maslamani sir can answer. In
Please.
India, are we producing engineers or engineering graduates? Mr. Ajay Kumar, student, Chennai is asking. In India, are we producing engineers or engineering graduates?
We are producing engineers. Why not? Why
Good
it's
question.
engineering graduates? Sir can answer this question
Another
very
question.
well.
Yeah, that's the
Yeah.
question.
Yes, we have seen so many
No,
people.
I would say it's a very good
Uh,
question.
yeah.
Okay, so to some extent, yes, we do bring out good engineers, but majority of them are, I would say, engineering graduates.
Graduates. Okay.
What is really missing is the exposure to the industry.
Okay.
In the curriculum, even in my previous lecture, I was telling there should be more and more interaction between industry and the curriculum.
Okay.
And students especially, should be asked to go to the factories, visit sites, take projects, industrial projects, and do them during the curriculum.
Okay.
So if we do this, we will bring out more engineers rather than more engineering
Any
graduates.
graduates. Okay. Thanks, sir. Thanks.
Thank
Thanks.
you.
Yeah. So this next question is by Miss Swati Kumar from Pondicherry. She wants to know about our placement records and placements in general for chemical engineering. So you,
Placement currently core company placements are some 30% we can say,
yeah.
and the remaining are remaining placements they get very well in the it is not only the software company placements, they are also put up in service based companies. Service based companies they are getting placed. So
Okay.
we do agree core placements are there, and service based companies are also getting yeah,
Okay.
they are still getting placed. So
Okay.
it is all about the industrial prospects. Now it is we cannot give any kind of guarantee because of the prospects current nature, but still it will not be the same thing. As I said, sine curve.
Okay.
The curve is supposed to come up. Certainly it will come up.
Mm-hmm.
Yes, you can very well tell.
Okay.
The next question can go.
Okay, sir. So the next question some of them are asking is in general, some of the parents are asking is like Jagdish and Shanta Marimuthu is asking cut off for our chemical engineering program at SCC. So
Cut
Cutoff marks.
Cutoff
I'm not
is
sure.
category based. It's a category based. It's a
Okay.
category based. OC, BC, MBC, like the category based. So we
Yes.
cannot do that. It's there and well displayed by the Anna University in the
And
web page. So they can see the category base, they can see the cutoff.
can we give a
Around
range, sir? Around
range,
190 to
like,
196. It is the range.
yeah, that is for the open category.
Open category. Yes.
Yeah, when the category comes down, we can. It's also
It will
happening.
less than that.
It
Okay.
less than that is also
Yeah.
happened.
So in general, 190 to 196 is for a general category.
Yes,
That is the
yes,
cutoff
yes,
of
yes,
SVCE.
yes. That is correct.
That is correct. Okay. Another question is: are there any extra skills required to learn while pursuing chemical engineering? Do you want to learn something more? This question is asked by Vijay Lakshmi from Chennai.
No, no. Extra skills, there, additional skills. Very well, you can. If time permits, you can very well pursue many things. You can also do language, all these things. It's all
Mm-hmm.
up to you. You can keep on doing it, but at the same time, your time should permit. That is
Mm-hmm.
also there. As Santosh was telling, he was very
Mm-hmm.
much confined with only the program. That also
Mm-hmm.
is sufficient. Right now, we have only the core program is only 40%. We still other knowledges also very much we cover up with open electives, many other things. We also expose them. So it
Okay.
is not very essential or must. If your time permits, you can very well do it.
Okay, sir.
Yes,
So I think pretty much.
Okay, can I answer
Sure,
yes, sir.
sir.
the
Yes, sir. Please,
Sure,
please,
question?
sir.
please,
Sure,
please.
sure.
Sir.
Yeah.
Can I answer this question?
Yes,
Yes,
Yes.
sir.
sir.
See, this again is a good question. Other than the technical
Mm.
aspect, what we teach here in the university are the technical aspects. Okay, this is a particular way, this particular processing to be done, and things like
Mm.
that. What is one more important thing is in the soft skill.
Mm-hmm.
When I say soft skill, how you express yourself to others, how you present yourself to others. This is very,
Mm.
very important once you come into industry. Okay,
Mm.
so you are not only a technical person, you have to be a managerial person also as you grow up in the industrial organization.
Okay.
So along with the technical skills improvement, you have to develop your soft skill also. So
Okay.
you have to talk and do. You cannot be only a guy who can talk or only guy who can do. You have to do both.
Yes.
So you have to develop your soft skills also as a part of your curriculum.
Okay.
So very much we give training, sir. We are giving training. All these trainings are being given. Currently, we give all sorts of training. Initially, as soon as the program is open, for the first 2 weeks, we give all the soft skill training is being adopted, sir. We do nowadays for the students. We do this. We do start with such kind of trainings, analytical training as well as the such trainings are happening, sir.
Yeah.
We have
Yeah.
exclusive people to train these things. Now it is happening, sir.
Yeah. Okay.
Very much it is happening, sir.
So that's good. Thank you,
Mm,
sir.
mm.
So
Good, good.
just to summarize, since it's mostly about the scope, I'm going to list some of the emerging technologies for the next 5 decades where the chemical engineers are eligible. Okay, so this is from our internet source only. So you can find in some of the upcoming fields in advanced materials, their chemical engineers are required in clean technology with respect to sustainability, bio and environmental treatment, their chemical engineers are eligible. In nanotechnology, in terms of developing medicine and products, their chemical engineers are required. In 3D printing, that is additive manufacturing, so their chemical engineers are required. In energy technologies, with respect to storage, decentralization, grid, there also chemical engineers are required. And in general, some other like artificial intelligence, machine learning, also chemical engineers can explore and find those applications for the chemical engineering field. So I just want to summarize that. And with this, we can end this Q&A session. And now,
What of thanks you can propose?
yeah, definitely, sir.
Mm.
So, so now I would like to, uh, I'll provide the feedback, online feedback form, the link in the chat box. Okay. So please, all participants, please submit that one by today so that you can get your e-certificate by tomorrow. Okay. So I would like to deliver my vote of thanks. So I take
Yes,
this
please.
opportunity to thank our expert speakers, Sri K. Masilamani sir, Professor S. Pushpavanan sir, for dedicating their time and effort for this event. I thank our dear alumni, Mr. W. B. Santosh and Ms. Bhuvaneshwari, for sharing their experiences. I thank our participants for their continuous presence throughout the event and following the webinar etiquettes. I thank our SVC management, our secretary, Professor M. Shivanandam, and beloved principal, Professor S. Ganesh Vaidyanathan, for their continuous support and motivation. I thank our head of the department, Chemical Engineering, Professor N. Mayappan, for providing me the opportunity to coordinate this event. My special thanks to Mr. Arun Prakash, Manager Admissions, Marketing and Alumni Relations, for his outreach to the participants. I thank faculty members of Chemical Engineering Department for their support, especially Mr. Sivakumar, Ms. Vijayalakshmi ma'am, Dr. Yogesh Kumar, Mr. Bharat, Ms. Yandeepa Priya, who helped in various instances. I thank our students, Ms. Yagna Madhavan, Mr. N. N. Harish Kumar, and Mr. Praveen Kumar, for their volunteer support. Once again, I thank everyone for all your participation efforts in making the event a grand success. Thanks. Just
Thank you
thank
all.
you,
Thank
thank
you
you
all.
all. So just wait, I will give the
Thank you
link,
all.
sir. I
Thank you,
will
sir. Thank
provide
you.
the
Yes,
link.
please.
Yeah,
You can
then they
provide the
can.
link. Yeah.
Yeah. So please
Santosh
stay
wants
for
to say
the link.
something.
Please stay
So, sir,
for
I
the
just
link.
Santosh.
Yeah, yeah.
Thank you.
Thank
Thank
you,
you.
sir.
Thank you.
Just 1 sec, I will send the link. Mm, okay. Participants, please see this link. I think hope you got the link. So please fill the form, fill the online form, and then you'll get
Yes,
the
please.
certificates.
Certificates.
Okay.
We thank you
Thank you
all.
also.
We
Thank
thank
you
you.
also. I will stop
Thank you
recording
all.
this one. Yeah.
Yes. Yes, please. Yes. Thank you.